Well, of course, the court thing may get in the way. Fit regression model. What's going to go in the response box? Whatever you're trying to predict or explain. So in our case, sorry, this is kind of like that will still be price. The only thing that's going to change is instead of having just one variable in here, you're going to have multiple variables in your predictor box. So for our first model, let's look at just doing, well, square footage and setback. Let's start with just those two. Just to kind of ease us into multiple regression. So we're going to include square footage as a predictor. And we're also going to include the setback variable as a predictor.
Do you have to put a comma between them?
You do not. Just click on each one. Double click on each one, throw it in the box. And it doesn't matter which order you put them in either. Just make sure your predictors are in the box there. And again, let me define setback. Setback is how many feet off the road your house is. So I click OK, and Minitab pops up a regression analysis for us, square footage, setback. Now, once we have multiple predictors, this is where there was something I started to talk about last chapter, but I decided not to, because when you just have one predictor, there's actually two different types of hypothesis tests we can do on a regression model. What we did on the test y'all just took, we did t-tests for like square footage to see if it was significant or not. But notice up here at the top, there is an analysis of variance table. It has an F value and a P value and all that. There's really two different types of hypothesis tests you can do with a regression model. But in the last chapter, when we only have one predictor, these tests are identical. They give you the exact same result. They're going to have the exact same p-value. I mean, there's no reason to do both tests if you only have one predictor. Once we move to multiple predictors, though, we do need to be aware of the two different hypothesis tests that we can do. So you get Minitab to do your regression model. Actually, before I do the test, let's do what we usually do here. Let's look at the regression equation. The regression equation, and I'll run it again so I can scroll up. Let me run that guy again so we can scroll up. So there's my regression equation. Regression equation. Square footage has a plus sign on it, right? What does that indicate? Bigger house, bigger price. Setback also has a plus sign on it, right? What does that imply? More setback, more price. So, you know, so far it's just like it was with one predictor. Look at your signs. That tells you whether this tends to make price go up or down. Both of these are positive, so both of these suggest they make price go up. Now let's think about interpreting these things. So my coefficient here on square footage is 182. Now last chapter, how would we have explained that 182? What did that mean?
Whenever square footage, the price goes up 182.
So when square footage goes up 1, price goes up $182. We still explain it that way, but we have to make a little kind of disclaimer here. The interpretation is a tiny bit different now because we have these multiple explainers in the model. So we have to incorporate that into our interpretation. It's pretty much the same as we did in the last chapter, but we got to put this little, like I said, a little disclaimer on there. If I want to interpret that 182, I would say, well, there's a couple of ways you can phrase this. I'm going to phrase it this way. Holding setback constant. And I'm actually going to put the other interpretation in parentheses because there's two different ways that, you know, they both mean the same thing. So either say holding setback constant, or you could say already accounting for So you have to put this little disclaimer in there first, because what you're saying, essentially the difference between this one predictor model and a multiple predictor model, this is not the entire effective square footage. This is the extra effective square footage after I account for setback. So after I account for how far off the road the house is, this is the extra effective square footage. So you have to state that, you have to make that clear. This 182, that is the extra effective square footage above and beyond setback. So holding setback constant or already accounting for setback, then you can say each extra square foot price goes up $182. So that last part is like it was before. Each extra square foot price goes up $182, but we have to acknowledge this. What we're doing essentially is, again, we're saying this is not the total effective square footage. This is the extra effective house size after I've factored in setback. And this will make more sense as we keep doing this, as we keep getting used to this. It's the same, you just have to acknowledge this is the extra effective square foot. Just think about it. If I think about, I don't know, if you've ever driven down, what is the name of that road? Indicator, like Country Club Drive or something? Parallel 6th Avenue, but it's over here. They got some big, nice houses, and they tend to sit pretty far out back off the road. This is saying, if I had two houses, and they both had the same setback, this is the extra effective square foot, already accounting for both those houses sit way off the road, then this is it's kind of like in economics. Have y'all taken your economics classes?
Yes.
Some of you? All right, I'm gonna put you on the spot. Have you taken microeconomics, 232? If you took 232, you talked about marginal concepts, marginal utility, marginal cost. What is marginal cost?
I don't remember.
That was a long time ago.
It was like last semester and I don't remember.
All right.
It's your first piece of pizza is great.
Shouldn't
and,
you
like,
know,
it's
cost
really
of
nice.
Okay, that's
Total
utility, marginal
utility.
utility. Marginal utility, we can go with that, is the extra utility from one more. Marginal cost, the extra cost of making one more. It's not the total cost of producing something, it's the extra. That's what marginal means in economics. You can kind of think of these as marginal effects. After we account for setback, this is the marginal, the extra effective square footage. So, how would I interpret the 721 on setback then?
Holding square footage constant for every, is it feet?
Feet.
Every feet of setback is an extra 721.
Exactly. You still do it the same. You just have to put that little disclaimer in there. I'm already accounting for the size of the houses. So two houses that have the same size. If one of them is 1 foot further off the road, it's gonna cost $721 more. That's what that coefficient is telling me. It's got nothing to do with size. I'm holding size constant. I've already got size in my model. This is the extra effective setback after I account for square footage. This is the extra effective square feet after I account for setback. It's just a little, like I said, just a little disclaimer you have to put in there, sort of acknowledging this is not the total effect of the size, this is the extra effective size after this guy's already been accounted for. All right, so I want to introduce that to you first. It's very similar to the last chapter. Like I said, you just have the little holding everything else constant disclaimer thrown in there now. If we wanted to predict the price of a house that was 2,000 square feet and had 150 feet of setback, could we do that? How would you do that?
Substitute the square footage.
You would put 2,000 in for here, multiply it by 182, put 150 in here, multiply that by 721, and subtract. And why are we subtracting? Because the intercept estimate is negative. It's just like last chapter. We just have one more term we have to account for here. So I think y'all can do those. I mean, if you could do this last chapter, you can do it this chapter. The thing that is different though, that I wanted to talk to you about that is fundamentally different, Well, I'm gonna have to scroll